Hi, everyone. My name is Agnieszka Słowik. I'm a PhD student at the University of Cambridge. Welcome to the Women in ML in PL panel discussion. We are honored to have 5 amazing panelists joining us today. Dr. Bianca Dumitrascu from the University of Cambridge, Professor Marta Kwiatkowska from the University of Oxford, Professor Ewa Szczurek from the University of Warsaw, Maja Trębacz from DeepMind, and Dr. Liesbeth Venema from Nature. Right, before we begin, I'm going to ask the panelists to tell us a bit more about themselves. Let's start with Bianca. Bianca, could you introduce yourself, please?
Sure. Hi, everyone. It's a pleasure to be here. I'm an early career research fellow at the Computer Laboratory in Cambridge University. I'm part of this new program called Accelerate Program for Scientific Discovery, which is a new initiative meant to bridge connections between scientists and data collectors with computer scientists. My group is developing statistical and machine learning methods for understanding self-aid decision-making. And we're very much interested in interpretable machine learning and hypothesis testing in order to make experimental design more efficient, but also to extract more information about how cells impact normal development, but also disease.
Thank you. It's great. Right. Marta, would you like to tell us a bit more about yourself?
Hello. Good evening. Dobry wieczór. I'm Marta Kwiatkowska. I'm a professor of computer science, of computing systems at the University of Oxford in the Department of Computer Science. I'm also a fellow of Trinity College, Oxford. It's not the same as Trinity College, Cambridge, but it is still a very nice traditional college. What I'm working on is automated verification, which for the last 5 years I have been applying to actually verify robustness of machine learning solutions, deep learning neural networks with applications in image classification, videos, NLP, and more recently we've also started looking at robustness to causal interventions. Thank you.
Thank you, Marta. It's very interesting. Right, on to Eva. Would you like to tell us more about yourself?
Yes. So hello, everyone. First of all, thank you very much for the invitation. It's a great pleasure to be here. And about myself, I am working as an assistant professor and a group leader at the University of Warsaw, at the Faculty of Mathematics, Informatics, and Mechanics. And our group currently works on developing machine learning methods, which can be broadly divided into 2 types of methods. One of them are probabilistic graphical models. Others are deep learning with a recent focus on variational autoencoders. And all of these methods are in the lab are usually also sort of meant to be applied to some medicine-related problem. So the medicine problems that we currently work on are oncology, so cancer-related problems, generation of antimicrobial peptides, or COVID-19 epidemiology.
Right, thanks. Thank you very much, Eva. Liesbeth, would you like to tell us a bit more about yourself?
Hi, everyone. I am Liesbeth. Thank you very much for the invitation to this panel. It's a real pleasure to be here. So I was a physics editor at Nature, and in 2019 I launched with a team of editors a new journal, Nature Machine Intelligence, which focuses on AI, machine learning, and robotics. It's been a very exciting time. We are very excited to see a lot of really innovative work in AI and machine learning applied to other scientific discipline with very transformative applications. We also handle a lot of commentary articles on the impact of AI in society, questions about policy and regulation and ethics. And at the journal, we have a very strong focus on open science topics, so in reproducibility, availability, and sharing of data and code. Thank you.
Thanks, Liesbeth. All right, so on the topic of nature and machine intelligence, let's move swiftly to the DeepMind representative, Maja.
So, hi, my name is Maja Trębacz, and I am a research engineer at DeepMind. Quite recently, in 2020, I graduated from Masters in Machine Learning and previously undergraduate in Computer Science at University of Cambridge, which makes me the only person in the panel without a PhD. So I am very happy that I was invited to such a great crowd. And in the meantime, at my university, I completed software engineering internships at Amazon and Google, and also research internships at DeepMind and X. In terms of my machine learning interests, I like to consider myself kind of a generalist because I have worked on various projects related to applications of ML to cancer research, on open-ended learning in vast universe of multi-agent games, also applying AlphaZero to new domains, but also language models and participatory machine learning. So in the reinforcement learning vocabulary, you could say that I prioritize exploration over the exploitation of specific research areas.
Yeah, it sounds good. Thanks. Thank you so much. All right. So thank you, everyone, for this round of introductions. Let me introduce the panel. In this panel, we are going to discuss two topics: career advice and future of machine learning research. I'm also going to ask a question from the survey that was sent to the conference participants ahead of the event. But don't worry if you are in the audience and you have missed the survey, because we also have the Q&A. And feel free to ask your questions. Time permitting, I'm going to ask them at the end of the panel. Right, so let's start with career advice in machine learning. The first question is for all the panelists. How did you start your career in machine learning? And how did you get into your current line of work? Let's start with Eva.
Okay, great. So I was actually interested in what we call now machine learning, but back a long time ago, it had many different names. So I think the most, let's say, trendy name for it back then was data mining. And I was generally really excited about different algorithms that can help draw conclusions from data, or better analyze data, or you learn based on data to predict something just very early on. So it was a very easy path for me in a way, because I got very excited about it already during my master's. And also during my master's, I already got into applications of machine learning in computational biology. So I have two master degrees, one of them from the University of Warsaw and another from the University of Uppsala in Sweden. And the master's in Uppsala was actually a really was already very much computational biology oriented. So there I learned about the sort of typical problems, but then I also back then already tried to think how can we apply these data mining back then algorithms to solve these problems. And that just continued on during the PhD and postdoc and in my own lab.
Right. So yeah, that's very interesting. So in your case, the interest in data mining was parallel to the interest in computational biology, and you're still working on the related topics, right?
Yes.
Yeah, that's really cool. Right. Liesbeth, how did you start working on nature machine intelligence?
So as I mentioned, I actually was a physics editor. So my background is in physics. I did my PhD in physics, and sort of near the end of my PhD work, I realized that the aspect I was most interested in was in the science communication elements of the research, and so I applied for a Nature editor opening, which I was happy to then get. So as a physics editor, I found it one of the most exciting aspects of a science editor job in general is that you can read about lots of new topics, new areas, so you can see new topics coming up. And I realized around 2012, in between 2012 and 2015, that the future for many scientific areas would be in AI and machine learning. Those topics, those tools would have a transformative effects on many other research areas, including in physics. So I was very happy that the Nature group decided to launch a journal in this space. Which is how I got into machine learning. Thank you.
Thanks. Thank you so much. Bianca, would you like to take it?
Sure. Well, in my case, I kind of started my journey in the math department at MIT, where I did my undergrad. And I was very lucky there because we were forced to take some introductory classes in topics that were very different from our interests. So as a first-year undergrad, I was forced to take an intro to biology class. And this was a terrific class. I didn't speak English very well, so it was kind of hard because the problem sets and the exams were so wordy, and I was very used to very short answers like prove this, prove that, let X be blah. And it was such a weird exercise. And the professors of the class were Bob Weinberg and Eric Lander. And Eric Lander is a mathematician at heart, and they really emphasize the fact that genetics and biology have and require a lot of fundamental mathematical understanding and statistical understanding. And from there, I got quite interested in all these genomics problems. At the time, there was a lot of interest in understanding the human genome. There was a big effort in collecting data related to the human genome. And I took advantage of a couple of undergraduate research opportunity projects, which are quite popular at the university. So I was very lucky to be in Professor Bonnie Berger's group, who at the time was very welcoming to, and still is very welcoming of undergraduate researchers to just stay around, come to lectures, interact with graduate students. My first project was on RNA folding. I didn't make my progress on it. I just read a lot of papers, and I haven't really worked on that problem since. But everyone was very nice and very welcoming, and I continued to take classes. I took my first proper machine learning class was Tommy Yakola's probabilistic machine learning class, which was a graduate class, but I sneaked into it, and I quite enjoyed the material. So I decided that I would like for my PhD to combine the two and maybe work in a place where that is possible. So I chose to do my PhD at the Louis Sigler Institute for Genomics at Princeton University, and there I was very lucky to be in Barbara Engelhardt's group, who's a computational biologist that really emphasizes the interaction between statistics and genomics problems. So I think for me personally, my interest in machine learning has been this desire of learning more about math and probability and statistics in the context of biological problems. And at some point, machine learning and statistical machine learning was quite the necessary ingredient to think about this exploding field of data and data aggregation. So I've been in the field ever since.
All right, thanks a lot. Let me have a follow-up question then, since you mentioned your background in mathematics and your preference for, strict and universally understandable language of mathematics. Do you have any advice for people who are also doing an undergrad in maths and they are considering a career in machine learning?
Yeah, actually. So I think I cannot speak about proper mathematical research because I haven't gone that route, but I can speak to the fact that I think the best thing that they can do is have a very strong foundation in linear algebra, probability, and statistics. And I think an understanding of these particular areas will really help them long term. I think, usually there's a lot of, we live in a field that's evolving very fast. There's hundreds of publications every week on particular topics. I think going back and taking things slow and trying to understand what are the problems that are worth asking and what are the questions that we still don't understand is quite important, and having this foundation in linear algebra will really help long term to understand what things like attention networks or transformers, what are the core modules that really make them work. So I guess this is, and also real analysis. I think real analysis is always really, really helpful for everyone. I don't know, maybe I'm just biased.
Right, that's great. Thanks, thank you so much. Right, so now on to Maja. How did you start your journey in machine learning and specifically in research engineering?
Yeah, so it wasn't clear for me from the beginning that I want to study computer science, but once I started studying computer science, I caught my interest in machine learning pretty early on. I had a really nice introductory course in my first year. So I enjoyed learning it, and it caused me to explore the field further. But knowing that it is popular and very competitive area, I strive to make my qualifications as high as possible very, very early on. To be fair, I started my first job in computer science IT area when I was 18. That was still back in Warsaw in some insurance company. And also later during university, I did multiple software engineering internships to develop on this front. Then, and simultaneously, I was paying attention to the topics that Bianca now mentioned on the research edge. Then I was very fortunate to get into the first cohort of research engineer interns at DeepMind. So I got a taste there and really enjoyed being on this verge of academic research and industry, as well as on this verge of doing engineering and research at the same time and being able to be flexible in those two areas. So I really enjoyed the environment and decided to stick around for longer after finishing my master's in ML.
Right, thanks Maja a lot. So would you say that in order to become a research engineer, is it a better investment to focus on software development skills and software development internships as you did, or which proportion of research needs to come into play? Yeah,
definitely it's also the fact that it's a bit hard to do high quality research during your undergrad, as this comes later and requires more knowledge. definitely as a research engineer, you need to be good at both. So it requires wide range of abilities, both in research and engineering front. So, and the best way of getting the engineering experience is through internships, through work, through different engineering projects, in order to be able and learn how to develop high quality code. So I definitely recommend starting on that front early on, and simultaneously working on the research knowledge and maths background.
Right, thanks a lot. Marta, how did you decide to focus on machine learning as a professor in computer science? And how did you get into your latest line of research?
Okay, so I'm a computer scientist. I actually got a degree in computer science, Informatica, in Poland from the Jagiellonian University many, many years ago. I then moved to the UK to do my PhD. Now, because Informatica in Poland at that time was very theoretical, I had very strong theoretical grounding, and I focused on theoretical techniques. And for more than 20 years, I have been working on automated verification. So the idea is to develop theories, but also algorithms that would take a model of a system. It could be a probabilistic model of a protocol, for example, and the property which is specified in temporal logic, and the system will then answer yes or no, or perhaps also estimate the probability of some good or bad thing happening. So I was very much used to rigor. Now, in 2015, I got a large EPSRC program grant, which was jointly with the Oxford Robotics Institute. And I had a role within it to actually apply these verification techniques to safety and trust, to analyze safety and trust of robots. And now in these conversations, at one point, Paul Newman, who is the lead of the Oxford Robotics Institute, and he was the principal investigator of the grant, he said, oh, you know, you are working on software verification. We are developing this controller. How about you take a look at this controller and perhaps try to see if you can verify its correctness? So he showed us a large code base, which was all written in C++. And we discovered that what the software was trying to do is to do real-time object detection for applications in autonomous driving. And they were also working with LiDAR at the time. This was not a deep learning program, but it was a machine learning program. Now, so I thought about it. Well, I mean, you know, what I can do, verification of the outer envelope, but the really interesting object for me was, you know, the software, the machine software within it. And I knew that machine learning existed, but I didn't know, you know, much more than that at that time. And when I started reading more about machine learning, I discovered that what was happening there, because people were very excited about new applications and they were just pushing for better and better performance. So no one was thinking about rigor. And in fact, it was actually quite fashionable to say, oh, we actually don't know why it's doing this. We know it's doing this, but we don't know why it's doing this. So I basically started questioning this. And I was fortunate that I then had a sabbatical in 2016. I went to Berkeley for 2 months. I visited Google and various other places. So I met Christian Szegedy, for example, of the adversarial examples paper. So I've learned a lot more about machine learning. And then, you know, I actually gave a keynote at the main verification conference on the need to actually do verification, robustness verification for machine learning. And I think this has really resulted in a shift within my community to actually start looking at these applications. And now I'm looking not just at machine learning, but more broadly AI, so agents, multi-agent systems, and automated decision-making.
All right, thank you so much. Let me just ask one follow-up question to wrap it up. Marta, would you have any advice to someone who is currently looking to follow into your footsteps? So let's say someone who also has a background in computer science and would like to do work in academia as a machine learning researcher.
Yes, so I think, to start with, try to get exposure to the topics that you are interested in. But I would say, don't forget, you have to focus on understanding what's going on deeply. It doesn't have to be mathematically, but you really have to understand what's going on within it. And don't be afraid to question even the status quo or hype, because there could be a lot of hype, there could be a lot of advertising and pushing for a particular position. But it's a very exciting area. It's a very fast-moving area. And, it's an area where people with all kinds of skills can find a niche.
All right, thanks. Thank you so much for sharing your experience. Before the panel, we also created a survey to collect questions that the audience might be most interested in. And it turned out that the most popular questions were around imposter syndrome. So this is a somewhat more personal question. But if you've ever experienced the so-called imposter syndrome in your career, do you have any advice on how to manage it? That's an open question, whoever wants to take it.
I can start that I definitely experienced that in my career and multiple times thought that that I am getting a position where someone else could be more qualified to get it. But I would say the first step to managing is to realize that actually almost everyone feels that way. And if you ask people, it turns out that a lot of people, I feel that, like, especially women, do feel the imposter syndrome at some point. And once you get this idea that you're not the only one having this feeling, it helps to realize and fight with it.
Right, so would you suggest connecting to others who might also have imposter syndrome? But do you have any advice on how to do it, right? Because maybe not everyone would want to share it immediately. So did you have experience with, I guess, bonding over other students when it comes to imposter syndrome?
Yeah, it's definitely bonding with other students and also other coworkers. We had this meeting at DeepMind that was women at DeepMind lunches, and someone asked this question, like, who ever felt the imposter syndrome? And as cliche as it sounds, everyone in the room raised their hand. Everyone from super capable and impressive researchers that I knew and I perceived as the role models admitted that they do feel the imposter syndrome.
Yes, Bianca, go ahead.
Yeah, I just wanted to focus on the part of the question about how do you deal with it. You know, I'm trying very hard to focus on the things that I like about my work, and I think that sometimes it might be helpful, as hard as it is to ignore it and kind of not ignore it, but embrace the fact that you're in a place where you have a lot of opportunities and excitement for the things that you like to do, and remind yourself remind yourself what are the things that you really enjoy about your work, and understanding that you're not alone in this process could be really good. Finding mentors, trying to find mentors that you feel comfortable talking about imposter syndrome can be very important. I feel very empowered when I find other colleagues that I can talk about openly about why I think certain problems, so anyways, like finding good friends and peers that you can share these feelings with and discuss them openly is important. And I think this goes in hand with what Marta was saying, also to not feel comfortable to question the status quo. Sometimes imposter syndrome can come from the fact that you think that maybe you don't have an outlet of how to question the status quo properly. And having a good relationship with colleagues and being able to be honest about this is very important.
I really second Bianca's thoughts on this, and especially the aspect also where you really have to focus on what you love about your work, find things that you enjoy doing, because the imposter effect is something that will probably, I mean, you can fight it. And it will disappear, I think, as time goes. As you grow older, you grow more confident, hopefully. But the fact is that it probably won't disappear completely. So you don't have to fight it. You can find ways to live with it. Definitely find like-minded people. Absolutely, which I think are panels like these, workshops for women, networking specifically for women, are great occasions to be finding like-minded people, and you will see that everyone has the same issues.
Yeah, if I may add something very short, I agree with all that has been said, from the fact that everybody actually has it, to the fact that it's important to realize your core in a way, right? What is the thing that you work on, and how do you feel in it, and focus on it. But I want to add something that I think I learned during my life, that it's really okay to admit that you don't know something. And I think that it's very helpful in this respect. Yeah, and that's it.
So I just wanted to say that I also suffered from it. And I think here in this community, we are all women. But in my life in the UK, in contrast to what my degree was in Poland, where I was 50-50 men and women, my life in the UK has always been in a huge minority. So there are actually very few mentors that you can discuss the imposter syndrome with. I'm sure men suffer from it, but they would actually not want to discuss it. I don't have any good solutions other than, well, you need to try again and you need to, improve.
Sorry, I will add one more thing. I just found out in Wikipedia that the being afraid of being incompetent, so exactly the imposter syndrome, is actually the fear number one in CEOs, in large, like really highly, really high level people. In big companies across the world. So it's maybe, I'm sure men have it. It's just that maybe they speak less about it.
I also just wanted to point out one resource about this. I found that the community in Women in Machine Learning to be a very good networking environment, and they usually hold a lot of events at top computer science conferences. And I would really encourage everyone to look into such events or try to submit abstracts through that venue as well. It's been an environment where I was able to find a lot of mentors to help me with my research and my perspective about my career. So at which stage you are, I would really encourage you to look into the Women in Machine Learning initiative.
Right, so I can just add from myself that I second that, and I definitely recommend Women in Machine Learning as the workshop, and Women at CL from students from Cambridge and Oxford, and all these initiatives. Right. So in this case, we can move to the second part of our panel, which is going to be focused on the future of machine learning research. So the first question is going to be, what do you think is the likely future development of your field? Is there a promising topic that is only now being explored? And let's start with Bianca, if that's okay.
Sure. I mean, I can tell you something that's very biased from my perspective. In computational biology, we continue to make discoveries at the level of improving the experimental techniques that we can get data from. And one of the most interesting modalities that I've come across is the fact that in microscopy and imaging particularly, we have this new ability to track thousands and millions of cells in developing organisms to see how the cells assemble themselves in tissues and organs. So I think one of the directions I'm very excited about is understanding cell trajectory from the purpose of cell movement, interspecies comparison, trying to understand how particular mechanical and chemical cues get integrated to understand gastrulation, for example, in the developmental embryos across different species, and how the nature come up with solutions to minimize all sorts of constraints from the environments will be quite exciting. So from the machine learning point of view, I think one of the things I'm very excited about is how do we think about natural biological phenomenon with the help of multi-agent systems? How do we understand emergence of communication in this context? And how do we build robust interpretable machine learning models that are not only able to predict where cells end up, but also try to understand what are the information that leads to this particular aggregation will be very, very important. And finally, I think machine learning for material science is something that's been quite popular in the past few years and continues to grow. Understanding how we can parameterize surfaces and understand folding or compression of different and properties of different materials using machine learning is quite exciting.
Thanks a lot, Bianca. It's great that you're mentioning this connection between machine learning and scientific discovery. And what does it look like from the perspective of the chief editor in Nature? What do you think is the likely future development in, let's say, machine learning for scientific discovery?
Exactly. I wanted to say that, as I also said before the start of this talk, of this panel, is that we are really excited to see many very innovative and imaginative applications of machine learning and AI tools, a very well motivated scientific applications. So not just throwing a bunch of machine learning models to a problem, but actually singling out a specific task, outstanding challenge in a scientific area, and having a very principled way of tackling that with state-of-the-art machine learning. So this, if I can mention a particular area, it's in drug discovery and materials discovery. We see a lot of very exciting work using generative approaches, and also models from language processing. So a lot of transformers are being used in drug discovery. Another completely different area is what I am very excited about as a physicist is that physics and deep learning or machine learning have very deep links with each other since the 80s, and they've sort of disappeared from each other's side a little bit, but in the last 10 years there's a lot of overlap between physics and machine learning. Statistical physics approaches are being used to help understand the fundamental principles of deep learning. And yet, one last area is in emerging machine learning and quantum computation or quantum simulation.
Right. Thank you so much, Liesbeth. And Marta, what is the likely future development in robustness for causal effects?
Okay, well, I would broaden it to robustness, generally robustness for AI. And I think by AI, I mean multi-agent systems. This was mentioned, but multi-agent systems where some agents are humans, other agents are artificial. And the idea is then to ensure that they collaborate effectively and in a beneficial way. This is a challenge, I think, for robustness in the longer term. But I think at the modeling level, what I think we will be seeing, because we need these agents, artificial agents, to make decisions in a more human-like fashion. They need to be able to read humans. If you think of, for example, various kinds of assistants or babysitters for kids, they would need to be engineered differently. So I think what we will need is we'll need to develop models that draw on cognitive science, on psychology, maybe even on neuroscience, and develop mechanistic sort of formal models of behaviors that incorporate this kind of cognitive reasoning.
Thank you so much. Do you also collaborate with neuroscientists and psychologists in your research?
Not yet with neuroscientists, but I did think about it. But yes, with cognitive scientists.
Right. Okay. Eva, would you like to take this question?
Sure. Yeah. This is an exciting question. Yeah. So yeah, I'm of course also, let's say, biased to my own field. And what I recognize in my field is that we have a lot of very highly dimensional data. So this is generated from high throughput experiments, molecular experiments with multiple modalities. And I see two major challenges that are coming up from this. So one is a challenge of data integration. So we want to have models that can reason from such really heterogeneous, highly dimensional data, and that can combine that data and somehow find out what are the key variables that are actually not observed usually and that are hidden, and how to find their states, how to find meaningful hidden representations that are lower dimensional but still convey like this huge message that we get from that raw data, so to say. How to find a hidden structure in that data and how to use it then to predict other variables of interest. And a second challenge is actually something what already Liesbeth mentioned. So I'm super excited about generative models. And so we have all that data, right? This what I said, this high. So if we learn how to model this, I think the next step is then to use it to generate new things. And in biology, we have a lot of beautiful applications of that. So starting from, just generating new samples that are then in silico generated, filling in missing, a lot of this data is actually very sparse. You can use it for filling in missing variables. But I think like the super exciting thing is like to really generate new things that are useful. Like, for example, molecules that will have some desired properties. What I would say is very exciting for me methodologically and is actually applicable to these areas are combinations of models that are deep learning models and probabilistic models. And when you have probabilistic models, probabilistic component, you get this generation property in a very elegant way, I think.
Thanks a lot, Eva. A follow-up question. Is there any specific application that would make you so happy if your research, sorry, it's too late on Saturday. So is there any application where you'd really like your research to show or to contribute?
Yeah, okay, and again, this will be super specific for my own research, but we actually have developed a model which is a generative model for antimicrobial peptides. So we are sort of writing up a paper where we have a conditional variational autoencoder for generating new sequences of peptides, and we have managed to show in the lab, like not me personally, but our collaborators found that we managed to deliver 2 peptides that were actually, like one of them was actually working more, like better, more efficiently in killing these microbes than sort of original prototype sequence that we have analyzed. And that I find amazing, that I generate, a model just popped out a sequence, like it's for me as a computer scientist, this is a string, right? This is like, ACD or amino acids, sorry. But then like someone actually synthesized this into a peptide in the lab, and it works. And for me, this is amazing. But there are many more applications of such sort of thinking, yeah, you can actually, all these famous generative models that, for example, produce art. Like you can have a Van Gogh, but you can also have like histopathological. You can generate histopathological images. We are now thinking of applying such a model to actually, let's say, provide additional imaging data for patients. We are working on now establishing a collaboration where there will be a lot of such training data on images on cancer patients, and one of the modalities is extremely expensive to do, and it takes a lot of time to do. And if our model could actually, add more measurements by actually being a generative model, I would be extremely satisfied with such an application.
Great, thanks so much. Let me use this opportunity to ask you, as an expert in computational biology, what do you think of the recent hype when it comes to molecular simulation and machine learning for drug design, right? Because there's the new company by Alphabet, Microsoft is also opening a new lab focused on molecular simulation. What are your thoughts on this new trend?
Yeah, I find it very exciting. I mean, I would like to, let's say, refrain from saying specifically, okay, it works, it doesn't work. So what I know is that a lot of this effort is about protein structure prediction, and there have been some let's say ways, different approaches trying to, different works trying to check how exactly how good it is, but definitely, it beats previous approaches, and it's very promising. And I see a lot of sparkling, there's more and more now coming up. So there are new methods for predicting now not only proteins, but then how protein complexes form, and so on. So there's plenty of new problems that will probably be now tackled. And I think we need a little bit more time maybe to actually see how really useful this will be. But I think these new developments open up a lot of new paths. but myself, let's say I have only worked on this peptide generator, and this here I can say a lot, but not on for example, protein structure prediction.
Right, that's great. Thanks so much. Okay, so let's move on to research engineering. Maja, do you think that JAX is going to be more popular than PyTorch?
Well, it definitely is a DeepMind, and I personally prefer it a lot. So I think that the answer is yes, but we will see. But in general, about the exciting things in my field, like I want to know that it's pretty hard for me to define what is my field in terms of machine learning. Being an early career research engineer, I don't have a narrow specialization, but rather like worked on variety of projects and jumped between things. And to be fair, I sometimes consider it a good advantage. Like we are not sure yet of what is the best path to creating the most impactful artificial intelligence. So being able to generalize quickly allows to stay on top of things and join the most exciting and promising frontiers of research at the current moment. Yeah, and to be fair, similarly as being a generalist myself, I am personally very excited about the models and agents that strive for such generality in terms of being able to solve multiple tasks and adapt to unseen ones. So this includes research I did in DeepMind as part of open-ended learning team, where with an aid of artificially created universe of tasks, the team trained AI agents that show general and adaptive behavior. So such agents perform well beyond just a single individual game or task, but rather can generalize to a massive space of challenges, and also, for example, can play now new unseen games and learn the rules quickly and perform pretty well on that. And after additional fine-tuning, perform super well. Another exciting avenue of models that have this amazing property of being generally pretty good at multiple things are the large language models. They were proven by already multiple companies to be a very good zero-shot and few-shot learners. That is, they can solve tasks either without additional examples or with just 2, 3, 4 additional examples of how to solve the given task. And they show human-level performance on huge variety of tasks, spanning from things like question answering, text summarization, or even maths problems. And I consider it pretty amazing, especially the ability to later take this model and fine-tune it on not too much data and make it really good at a particular task. And I think this opens up a pretty new paradigm of research and doing things, also allowing to train those with less examples. So yeah, that's a thing I am particularly excited about.
Right, thanks so much, Maja.
And the DAX helps with developing it.
Yes, definitely. Right, we are slowly heading towards the end of our panel. So let me ask one more question to wrap up, and let's try to end on an optimistic note. So can you think of any positive societal impacts of your research, either of your current research or of one of the many projects that you worked on in the past? And Marta mentioned human-agent collaboration and safety of robots. So let's start with you, if you don't mind.
Well, I think that pretty much sums it up. I think, the societal benefits, I think if we can manage to engineer robots and, automated decision-making systems that can make decisions with safety in mind, that are trustworthy, that are robust, and they sort of pay attention to humans, I think that would be a huge societal benefit. I think we are making progress. So I think we are making exciting progress, and sort of it's progressing fast, perhaps faster in some areas than in others. But it's a very exciting, I think, vision of the future.
Okay, thank you so much. The same question now goes to Liesbeth, and in your case, I'm going to ask a twofold question. So one, what do you think is the positive societal impact based on the papers that you are reviewing? But on the other hand, what do you think a positive impact in machine learning researchers community would be from, let's say, rigorous reviewing and the type of work that you're doing?
All right, thanks for that question. It's a very complex one. Maybe can I maybe focus maybe on the question of how the machine learning community in the last year has shown a lot of interest and concern about ethical societal implications of their work. So they're thinking about broader impacts. And this is something that at Nature Machine Intelligence we are also thinking quite a lot about whether we need authors to add things like broader impact statements in their papers, like NeurIPS has also introduced. So it's a very interesting. It's a really interesting topic because deep learning has, of course, come up really quickly, but without any ethical oversight. So the ethical oversight that you will get typically in the life sciences, this hasn't really happened in many machine learning fields. So yeah, the deep learning revolution was, for instance, fueled by scraping lots of images from the web without any question about consent or human rights or bias in the data. But these questions are now tackled, and which is very good. And we hope as a journal to also play a role in that. So we've for instance we've been part of the recommendations for researchers in AI ethics that's been developed by the Partnership on AI. And we are also developing a editorial policy for the whole of Nature, so for all Nature journals, on papers that have machine learning applications. So to think about issues such as the ethics of scraping data, using data, consent, human rights, and also on another level to stimulate researchers to think about the downstream consequences of their work.
That's great. Yeah, thanks, Liesbeth. Bianca, would you like to take this question?
Sure. One of the things I'm very excited about in the past few years is that the quality of academic software development has increased. The one thing that I'm really hopeful is that the new companies are also committed to open science and open sharing of the resources and discoveries. I think going forward, we need better benchmarks for enabling fair comparison across algorithms and approaches. And I think this is really, really important for advancing any sort of impact in the scientific community, at least. And the one thing that I guess it's hopeful, I want to stress that as a computational biologist, I think it's very important to think about machine learning as a way to encourage more scientific discovery, but not to replace the very genuine creativity that data collectors and real biologists or real experimentalists have. So I think for us to try to understand how we can work better with domain experts is something that I think we haven't figured out yet, how to create machine learning tools that really, so I'm very excited to hear about Eva's collaboration, and I think there's more effort to increase and enable communications between data scientists, computer scientists, and experimentalists. It takes time to develop trust and a language expertise to allow efficient communications between the two communities. And I'm very excited that with that awareness, there's going to be more improvement in terms of this. But yes, I think keeping the science open and sharing resources fairly will be central to achieving these goals. Thanks.
Right, thanks so much. Maja, would you like to add to this topic?
Yeah, sure. So regarding the societal impact of the field, I'm not sure that that any of my current work already had a chance to have any societal impact, but definitely I am excited about making it, I think, in the future. And in particular, I'm very excited about this movement of bringing AI to real world, like the labs you mentioned before, the isomorphic labs that started from Alphabet/DeepMind and that aim for AI first drug discovery. I find it super exciting that stuff that we do will get applied to real life and like have a potential of impacting drug discovery and therefore helping millions of people in the future. And bringing up the AlphaFold development into some actual processes of having the actual impact. So yeah, I find those things extremely exciting, and I have my fingers crossed for them.
Thanks, thank you so much. Eva, would you like to take this question?
Yeah, I mean. Okay, I can say maybe two things in that answer. So one of them regarding our own research in my lab. So because we work in this computational medicine actually, right? So we really try to tackle such problems that are related to oncology or COVID-19. So things that are already themselves like a burning problem to society, then I think I can claim that we are trying to have an impact, right? So for example, another model that we work on is actually like a huge recommender system that tries to essentially recommend a drug for a cancer cell line. And is also now we are extending this to have this generative aspect. So how to generate drugs that have specific inhibition, so specifically kinase inhibitors, how to have now a model that will generate itself a drug that has a specific inhibitory profile that we wanted to have. And these are, it sounds like we actually, we have this model, but it's actually very difficult to do this, that it actually works then in the lab. And I think I liked Bianca's comment. So I think we really need to, at least in our field, mine and Bianca's, we really need to work with people that understand what a drug is in that example, that understand how they work and what is the biology that underlines this mechanism that we are trying to somehow synthetically now model and mimic. And another example, it was we were trying to somehow analyze these histopathological images. These are images that are actually much less exciting than a lot what is happening happening right now. Bianca mentioned millions of single cells that are measured, and you can see them very precisely. There are some technologies when you can see proteins on single cells. You can even measure RNA in single cells and so on. But then these histopathological images, they are less technologically advanced, but they are exciting because they are available for every patient. Like in hospital, patients that have cancer, they have these histopathological images done, and we were trying to establish collaboration with pathologists. And in the first place, they were saying, "No, you want to replace us with these machines and AI," and it's not true, right? We actually want to do some boring stuff for them, but it will be always with our AI or deep learning. But I think they will be always in the center, and this so somehow even like posing the problems will still remain, at least for a long time, in the human charge. Thank you.
All right, thanks so much.